Hello, this is Aaron Daffern, creator of the 5-Minute Math video series. We are looking at the 2023 Math STAAR for 7th grade. I'm using a modified version of the item analysis report from the state. You can follow along by either using the QR code on the screen or looking at the link in the description. We will be looking at each item individually. You can jump ahead to any item by using the bookmarks embedded in the video or going to these timestamps you see on the screen. Number one, we are looking at TEK 7.4D, and this is a readiness standard in reporting category 2. So we need to find the ratio of almonds to raisins in this bag of trail mix, and they went ahead and gave that to us. So we've got almonds to raisins. So I'm going to put almonds to raisins. So they give us this ratio, and they even call that out for us, right? Is 4 to 3. So I'm going to use that in a fractional form here. 600 almonds in the bag. All right, so take a look. Almonds, that's going to be my numerator, so 600. And I need to find the number of raisins. All right, so let's say raisins is our x. So there's our proportion right there. So let's use cross multiplication. We know that if these are equivalent fractions, then you can multiply the numerator of one times the denominator of the other, and it's equal to the same thing with the other numerator and denominator. So that means 3 times 600 equals 4x, if x is the missing number of raisins. So that's 1800 equals 4x. Let's divide both sides by 4. So, right, because that's going to negate those two, give me x equals 4 into 1800. 4 goes into 18 4 times. That's 16. That's going to give me 20. There we go. There's a 5. We need to grab that other 0. It's not just 45, it's 450. That makes sense. That looks about right, like 600 over 450 equals that 4/3. All right, so our answer here is going to be D. Let's see how we did across the state of Texas. So this was the 16th easiest. We had 50% of our students get this correct here. We had a smattering of incorrect answers here. So if they got A, right, most likely students took a look at, we saw two different elements, right? There's almonds, there's raisins, and you just take your 600 divided by the two different types of food there, the almonds and the raisins, you get your 300. Students here, if you got your 150, most likely we're setting it up right here. 4/3 equals 600 over x. And they knew that they would need to divide by 4, so they took this 600 divided by 4, right? They got the 150, but what they failed to do obviously was multiply by that 3 to get up to that 450. So they did about half the work, but not all of the work. And then if we got the 800 here, most likely what we did is we actually just set it up incorrectly, right? See, that 4 is supposed to be the almonds, right? And the 600 is the almonds, so they both need to be in the numerator. But if they set it up incorrectly, if they put the 600 down as your denominator, now watch this. You get your 2400 divided by this 3, and that's where your 800 comes from. For number 2, we are looking at TEKS 7.6a. This is in reporting category 1. We've got some pizza here, and we can choose different options for our toppings, right? And so let's keep track of what we've got working here. So our topping options are going to be pepperoni or sausage. So pepperoni, and then we've got sausage. And then for our crust, we've got, looks like we've got a few different options here, right? We've got thin, thick, stuffed. So thin, thick, stuffed. Now this is a drag and drop, right? So we've got these different options right here that we can choose, and we might be able to use it more than once here. All right, so how do we fill this out? Well, this is just your basic probabilities here, and putting these options together. So pepperoni can have thin, pepperoni can have thick, pepperoni can have stuffed. And then sausage can have thin, sausage can have thick, sausage can have stuffed. So we need to figure out what's missing here. So take a look at our thin crust right here first. See, thin has got sausage. Okay, so that's this one right here. So thin is missing this pepperoni. Okay, so we need to grab that one right there. So thin needs to go to pepperoni. So let's grab this pepperoni, put it right there. Now I've got stuffed with pepperoni. All right, so stuffed with pepperoni. I'm just going to kind of shade that in. We got that. We're missing stuffed with sausage. That's the one we're missing. So let's get sausage right there. And then I've got thick. We're missing these two right here. So pepperoni needs to go with thick. All right, looks like we're missing this one right here. So pepperoni with thick. And then this last one is going to be thick with sausage. We're missing that one right there. So thick with sausage. All right, so just double checking. Let's make sure that pattern looks good. Pepperoni, sausage, pepperoni, sausage, pepperoni, sausage. And then thin, thin, stuffed, stuffed, thick, thick. There we go. We've got our answer here. Let's see how we did across the state of Texas. So as you probably imagined, this was going to be pretty easy. This was actually the fourth easiest problem on the entire test, and that's saying something since this was a drag and drop. It's a 2-point problem. We had 67% of the students in the state of Texas get both points, and then you have an extra 17% that just got one out of the 2 points. So put that together, you're looking at 84% of our students got at least 1 point, and a very, very paltry 16% got 0 points. So even though this did have drag and drop and there were a little bit of confusion possibly as to reading this once students saw the pattern here, it does seem pretty straightforward. You have two thins, two stuffeds, two thicks, and then you're just repeating pepperoni sausage, pepperoni sausage, pepperoni sausage. So you can kind of figure it out without even creating your own diagram. You can kind of see that pattern and figure that out. Number 3, we are looking at TEK 7.10a. This is in reporting category 2. So we need to take this real world situation, turn it into an inequality. And so if we read this sentence carefully, they give us exactly what we need here. A student rode a bicycle fewer than 30. So that's going to be our first clue. We need to take that. We need to say less than 30 during a period of 5 days. Right, so the student rode 8 miles on Monday, and then M miles Tuesday through Friday. So if I say Monday, Tuesday, Wednesday, Thursday, Friday, right? So I've got 8 miles on Monday, and then Tuesday, Wednesday, Thursday, Friday. All of that together is going to be fewer than 30, less than 30. So really, it'd be a little bit easier to say I've got 8, and then how many m's? Well, I've got 8 plus 4m. It's going to be less than 30, and that's what it says. So our answer here is going to be A. Let's see how we did across the state of Texas. So this was tied for the 9th easiest, with only 55% of the students in the state of Texas getting it correct. So to let you know how difficult this test was. The really interesting feature is look at option B, right? So that had 30% of the students choosing it. And whenever you see an incorrect answer getting such a high percentage of those incorrect answer choices, you always wonder what's the difference, what tripped them up. So we have 8 plus 4m, we have 8 plus 4m, so they're able to figure this out right here. Look at the difference. It's just the inequality symbol. And we've got right here, fewer than. All we had to do was interpret that. Fewer than. It didn't say greater than. It didn't say less than. We just had to find the synonym. Fewer means less. And that would be the difference between 85% and 55% getting this one correct, because those students were able to get this 8, and then it said 4 miles each day, so they had to interpret that for, Tuesday through Friday is 4m, so they were able to get that It all came down to just looking at fewer than. So this would be an opportunity for teachers to think of some other similar responses to fewer than, right? So you can have some synonyms like fewer than, less than, and same thing with greater than. What are some different ways you can say greater than? Well, you could say more than. It's more than simply just this less than or greater than. We need to find some synonyms for them to practice interpreting to make sure that they can interpret that correctly in a word problem. For number 4, we are solving scale problems. This is a readiness standard in reporting category 3, T7.5C. We have a student making a model of Washington Monument, and they give you the scale. So we've got 1 inch represents 15 feet, right? So we can kind of put that in a ratio here. 1 inch, 15 feet. And then the actual height is approximately 555 feet. All right, so that's kind of our clue is we want to, in the way we're setting up here, we want the feet to be in our denominator. So we need 555 in this second fraction right here. And then we're going to need to find the measurement in inches of that particular model. So we're missing, I'll just put X right there. So we know that we can use cross multiplication here. So 1 times 555, which is 555, is going to equal 15x. So really all we need to do then is just divide both sides by 15, right? That's going to turn that into a 1. And so we've got 15 into 555. It's going to go, let's see, 3 times. That's 45. That's 105. And needs to go evenly. So it's going to have to be an odd number there. Let's try 7. And that's going to be, yep, that's what we need. 105. And so there we go. 37 inches. The answer is A. Let's see how we did across the state of Texas. So this was definitely a softball question, our second easiest in the entire test. 73% of our students got this one correct. Now, how do we get some of these incorrect answers here? Well, if you look at 15, right, and you look at 555, you're thinking, well, 5 is kind of a common factor of both of those. And if you take this 5 and you multiply it by 15, you are going to get 75. So if students are not able to set up the proportions correctly, they're just going to start looking for various things you can do, and those both end with 5, so let's multiply something by 5. There's an answer. That's where we got that. 46 is really, both C and D are really looking at this relationship between feet and inches, right? So we've got 12 inches in a foot, and that's something that we know. And so maybe they, divided 555 by 12. That's going to get you approximately 46, not exactly. So that's possibly where C came from. And then this 180 is still looking at that feet and inches, knowing that there's 12 inches in a foot. Well, what happens if I multiply 15 times 12? I'm going to get 180. So you see here, if we get some of these incorrectly, what we're not doing is we're not setting up the proportion correctly. So this is an opportunity for those few students that missed it to really understand and set up, how do we recognize the proportion, how do we set it up, and then how do we use cross multiplication to solve it. So for number 5, we are calculating personal budget. This is TEKS 7.13b in reporting category 4. We've got a monthly budget for college, and we need to find categories that represent more than 10% of the total budget. Well, they give you each category. They don't give you the total. So step 1 here is let's go ahead and add this up. They conveniently lined everything up for us. So if we just keep our columns correct there, let's see, I've got 4, 1, and 5 make 10. So that's 19, and that's going to be 26. 2, 4, 5, and then another 5 is 10. All right, so 1065 is the total budget. I need to find categories that represent more than 10%. Well, how do I find 10%? I could either divide by 10, right? Or since that 10% equals 0.1, or I could just multiply by 0.1 or just move the decimal over 1, right? That's what happens when you divide by 10, you move the decimal over 1. So 106.5 equals, right, that 10% of that budget. So I need to find categories that are more than that. Well, it's pretty simple. Groceries are more than that. Cell phone is a little bit below. Rent is definitely more than that. And then it's that entertainment that's just a hair above it. Everything else is below. Groceries, rent, entertainment. Those are my three answers. Groceries, rent, entertainment. Let's see how we did across the state of Texas. So this was the fifth easiest question, even though this was a multi-select here, or hot spot actually. And you see 63% of our students got it correct. Put that together, right, with our partial credit, and at least 80% of our students, right, got 1 point, 1 or 2 points. Because what made this simple? Well, it's just 10%. So once you add it up, assuming we can add it up correctly, right, 10% is really easy to calculate. It would have made it much more difficult if it would have been 15% or 18%. It would have been a slightly more difficult calculation. But quite honestly, right, we know that we have only three correct answers and it needs to be more than 10%. You could have solved this without any type of calculation by just picking the three highest numbers. Because if you know if there's going to be three that are more than something, you could have just picked the three biggest numbers, this 250, the 440, and the 110, and you would have been correct. For number 6, we are making predictions using theoretical probability. This is in reporting category 1, TEKS 7.6D. So we have a deck of cards, contains 12 letters and 16 cards with numbers. And we have to pull, a card out from at random, and then it's going to be replaced. So that's going to be helpful because that means the total number of cards is not going to decrease every single time. You pull a card, look at it, put it back. So we're carrying it out 14 times. We're looking for a reasonable prediction for the number of times card with a letter. So this is a theoretical probability. We're not actually doing it. We're just predicting what would happen. Well, what do I know about my letter cards? Okay, I've got 12 cards with letters. So 12 letter cards. How many total cards do I have? Right? Because 12 out of how many? Well, I've got 12 and 16, right? So add those two together, you're going to get 28. So 12 out of 28, like slightly less than half of my cards, are going to be my letter cards, and I need to carry this out 14 times, right? An exact half would be that 14 out of 28, so it's going to be slightly less than, my half of 14, right? So right now I'm already looking at that because half of 14 is 7, so a little bit less than half would be 6. But how do we know for sure? Well, let's take this 12 over 28, right? That's my probability. If you want, you can simplify it here. Let's cut it in half. It's going to be 6 out of 14. Okay, we can divide that in half again. All right, so 3 out of 7. All right, so 3 out of every 7 times I'm going to pull one of those cards. And there's a total of 14 times, right? So I need to multiply this by 14. So I need to do that 14 times, or, if you want to, you can add 3/7 14 times. A little bit easier to use multiplications. How do you multiply that? Well, it's easy if you multiply when they're both fractions. So how do we turn 14 into a fraction? Any whole number can be turned into a fraction if you multiply it over 1. So you've got two different options here. So you could just multiply 3 times 14, divide that by 7. Right, so 14 times 3 is going to be 42. Divide that by 7 equals 6. Or you can do a little bit of this. You can say, all right, so if you take both of those and divide them by 7, that's going to be 1, and that's going to be 2. 3 times 2 makes 6. So there we go. Our answer is that 6. Let's see how we did across the state of Texas. So this was tied for the 14th easiest. It's a 38 question test, so it's right about the middle in regards to difficulty. And you see that our incorrect answer choices were pretty well distributed, meaning we either understood the correct proportion here or just kind of guessing at these incorrect answers. So how do we get some of these? Well, if you wanted to make A, right, you could have made an incorrect proportion. You could have said 12 over 16, right? Rather than that 12 over 28. And then you could have multiplied that by 14. It would have gotten you about 10.5-ish. which is kind of close to 10, but you see that's not even an exact answer. If you're looking at, 2, well, what you could have done is you could have said, all right, there's 14, pulling it out 14 times. There's 12 cards with letters. That gets me 2. That doesn't make any sense, but that's one way to get 2. And then if you got 12, you literally just said, oh, I see the number 12. There's my answer, right? Sometimes we're just identifying it. So really understanding how to set this up as a proportion, right? It's not 12 out of 16. It's that 12 out of 28. That becomes very, very helpful and very important for students to set this up correctly. For number 7, we are looking at slope-intercept form. This is a readiness standard in reporting category 2, TEKS 7.7a. So we've got to figure out this slope-intercept form, and then we have to find the correct numbers in tables. So let's set this up here. Remember, our slope-intercept form is going to be that very first line, y equals mx plus b. And so the bowling alley charges $6.50 per game, and then $4 for shoe rental. So this is something we need to recognize. Our students need to have some practice on is when you see a standard cost right here, that's going to be your B, right? That's your slope intercept form. In this case, this would be your plus B. That's going to be that y-intercept, right? So that's just the price to get onto the bowling alley is $4 for shoes, of course, unless you bring your own. And then $6.50 per game, right? So that's going to be my coefficient. So that's my M, that's my slope. Right there, that's $6.50. And then C, the cost of playing G games, right? So the C is the total cost, right? So that's going to be that. And then instead of X, they've got this G because it's per game right there. So all of these kind of match up. So it ends up being C equals 6.5 games plus it costs $4 to get there. So once we can set this up from, these few sentences here, well, you look what we've got here. We've got 1, 3, and 5, 1, 3, 5, 1, 3, 5. So let's just set this up and let's say there's one game. All right, so what does it cost if it's one game? 6.5 times 1 plus 4, right? That's going to be 6.5 plus 4. So that's simply going to be 10.50. That's cost for one game. Let's do the same thing for 3 games. All right, so 6.50, 6.5 times 3, that's going to be 19.50, plus still just the $4 to rent. That's 23.50. And then let's do the same thing for 5 games, right? So 6.5 times 5. Well, I'm going to kind of distribute that out. So I've got the 5 times 6 is 30. 5 times 0.5 is 2.5. Right, so that's going to be 32.5 plus the 4. That's 36.50. And then we're just going to scroll down. We're going to look to see if we have the 10.50, the 23.50, and the 36.50. You see it right there. Our answer is B. Let's see how we did across the state of Texas. So, like the previous one, this was also tied for the 14th easiest problem. So, right kind of in the middle of the pack of a 38 question test. So, how did we get some of these incorrect answers? Well, if you look at the responses for A, this student did set up the slope-intercept form. They just did it incorrectly. What they did is they most likely interpreted this as C equals, they had the 4 as the rate of change, and they had the 650 as your constant, right? That as that shoe rental, even though it's obviously opposite. And if you calculate this by 1 game, 3 games, and 5 games, that's what you'll get. That 1050, that 1850, and that 2650. So they tried to set it up correctly. They just flipped the two numbers, the 4 and the 650. For C, this student probably just saw that 650 per game, right? They thought that was just one game, and then they just added 4 each time. Right, so rather than using that as a rate of change, they just took the two numbers, they started with 1, then they added just $4 each time. And then if you look down at D, right, what do we have here? We just have the 650, right? C equals 650G. So apparently they just brought their own shoes because they completely excluded the shoe cost and just had the 650, each different time. And they thought that 650 was the game cost, rather than the shoe cost there. So we had that game cost, and they just brought their own shoes. So that's how we got each of those answers. For number 8, we are looking at circumference and area of circles. This is TEKS 7.9b, a readiness standard in reporting category 3. So we have a sundial, we have a diameter of 90 feet, and we're looking for the area of this circle. So we should go to our reference materials, and we see area, and kind of in the middle of the screen there, A equals pi r squared. So we need to use that as our formula that we're going to use. A equals pi r squared. And the only real thing that they can do to try to trip us up here is they don't give us the radius. All right, so here's the radius. This is a pretty good example of it, right? You start from the middle, and you go all the way up to one of the sides, or you can go down to one of the sides. But they don't give you the radius, they give you the diameter. So the diameter, I'll change colors here, is going to be all the way from side to side through the middle. So this is my 90 feet. But hopefully we see that if we take our radius, kind of move it down here, it's actually half of the diameter. So the diameter equals double the radius, or you could say the radius equals the diameter divided by 2. So let's take our diameter, 90. We're going to cut it in half, and that's 45. All right. So this is going to be 45 feet. This is going to be 45 feet. So now we can plug that into there. So A equals pi r squared is going to be pi and then 45 squared. So let's just multiply 45 by itself. Right, and that's going to be 25. That's 20, 22. And then we've got a 20, 16, 18. All right, so we've got 2025. Now we need to multiply this by pi. And remember that we do have the equivalency of pi is about 3.14, right down there at the bottom. So now we need to multiply this by 3.14. And it's going to get a little bit messy. It's a 4 by 3, but we'll go ahead and do it. That's going to be 20. And that's going to be 8, 10. That's 0, that's 1, and that's 8. All right, cross that out. Let's do the next row. The next row is easy because it's just 1. Right, so we're just going to write 2025. Next row is going to have 2 zeros because we're starting in that third spot over, and that's going to be 15. That's 6, that's 7, that's 0, and that's 6. If we can keep everything straight, right, and we can add everything up, that's going to be 15, that's 3, that's 6. Now we've got 2 digits behind the decimal in one of our factors, so we need 2 digits behind the decimal right there. So we're looking at about 6,358.5. And I don't see it up there, so let's scroll this down. Up there we go. Our answer here is D. Let's see how we did across the state of Texas. So as you could tell, this was pretty difficult. This was the 10th most difficult on the test. Our correct answer was D, and that didn't even receive the most answer selections. It was B. So what was it about B that got everyone all messed up? Well, take a look at the problem that they give you. They give you the diameter. And so when I'm looking at my reference materials, what do I see with diameter in circle? I see circumference, right? C equals pi d. And if I were to try to calculate that, C equals pi times diameter, right? That's going to be 3.14 times, and then my diameter of 90. And guess what that equals? That equals this 282.6. So students were just simply missing the fact that we were looking for the not the circumference, but the area, which is given to us right down here. But they looked at just that one piece of information we got, the diameter, and they looked to see what formula uses diameter, and they saw that circumference rather than the area. And then what do we do in regards to A? Well, A was just regrouping. They tried to do it right. Some regrouping errors. Now C is kind of interesting. They tried to do it, but if you were to do 3.14 times 45, right? So this is your radius. But what they did is that's pi r rather than pi r squared. So they didn't necessarily square it. That's how you get your 141.3. So we definitely need to have students practice how to find the circumference of a circle, the area of a circle, how to go between a diameter and a radius, and find the difference of the two. For number 9, we are looking at constant rates of change. This is another readiness standard, this time TEKS 7.4a, reporting category 2. This is a graphing problem. So we need to select 2 points on the coordinate grid that is going to represent this constant rate of change, and then a line will magically appear. So first, let's see if we can figure out which points that we might want to graph here, because there are many different points we can choose as long as the line is correct. This problem is looking for a correct line, not necessarily the correct points. So we've got a distance of 20 inches in half an hour. Okay, so that's our rate. So y is the number of inches. Okay, so y equals inches. And then we've got the distance, right, is going to be in x hours. Okay, so x is going to be hours. All right, so when we know that we're looking for rates of change, what we see here is we've got this constant of proportionality, right? That's going to be our constant. And that equals y over x. So our k is going to equal our y over x. So this case is our inches over hours, which they gave us as 20 over 1/2. Now, the difficult thing is we have a fraction in our denominator. But we can actually plot this here, right? So we've got x is 1/2, y is 20. So that first point looks like it's going to be right around there. And let's see if we can actually put that on there. See, we actually have a point right there at the half. So even though it's not on the grid line, we can actually put that right there. Now, what we need to do, let's just make a little table. What we need is a second point. Now, what we can do is we can go through the origin if we want to, right? We could say that we've got for half, it's going to be 20, right? So let's double that. Let's go for double half, that's going to be 1, right? And if I double 20, that's going to be 40, so I can do 140. And then if I wanted to double each of those again, right, I can do 2, and that's going to be 80, right? So 280 is going to be up here. And then if I wanted to, you see I'm adding 1, and I'm adding 40, so that's going to be 3 and 120. Looks like that's going to be that very top right there, 3 and 120. Now what I want to show you is that I can pick any of these 3 lines, or even that origin right there, since if he's not traveling, the 0 hour is going to be 0 since it is proportional. See how that is going to connect that line right there? So let's just pick a second point. I'll do the origin. And watch what's going to happen right there. It's going to make that line, and that's exactly the one that we selected. If I didn't want to select the origin, right, my second point could be one of these other ones. So what else did I say? I said it could be 280, all right? So I'm going to select, and I'm going to move that to 280. And I'm going to move that up there, right? And what we're going to find here is that if I move that, the line still stays the same, right? I could grab this one, I can drag it up here, and as long as I have it up on that 320, you notice the line stays exactly the same. So it doesn't really matter which 2 points we choose on this problem. It matters where that line is, and that is the correct line. Let's see how we did across the state of Texas. So this was a 1-point problem, so you either got it correct or incorrect. And we see this is tied for the 13th most difficult problem, and I think it really was due to the fact that this was a graphing problem. It's not as intuitive as we would like. Students definitely need extra practice on how to use this and to manipulate these and how you can kind of drag these dots around, because really you just had 1 point, and that's this line that we were looking here, trying to create. But honestly, it's the manipulation of these dots that might have messed some of our kids up. That, and in addition to the fact that, we did have this initial ratio here of this 20 over 1/2. And so they might have struggled with, what do I do if I have a fraction in the denominator? And obviously, we could have just made an equivalent fraction if we really wanted to just figure out, okay, so the ratio is 40 over 1. So we've got two different things contributing to our students' difficulties here. Number one, just the use of the graphing tool. And then secondly, the fact that we had initially a fraction in the denominator. For number 10, we are comparing numeric data. This is a reporting category 4 readiness standard, TEKS 7.12a. So we've got box plots, typing speed for students based on day, so Monday and Tuesday. And then we have 4 statements. One of them is going to be correct. 3 are going to be incorrect. So there's a lot of vocabulary here we've got to keep in mind. So median, right? So the median in this box plot, right, we've got our quartiles here, right? So this is going to be our first, second, third, and then fourth. I'm looking at these little lines in between the dots, right? So that's our first, that's our second, that's our third, that's our fourth. So it's broken up into 4 chunks, not equal, just based on the data. So the median is going to be that middle point right here, right between the second and the third. Okay, so that's our median right there on that first one. So that's going to be 70. That's our median right here on the second one. That's 65. And it says the median on Monday, 70, was less than the median on Tuesday, 65. And that is incorrect. So it is greater than. Let's check to see what we have for B. Maximum typing speed. So maximum, it's just going to be the final right there, was on Monday, so that's going to be 85. They're both 85. So they think Monday 85 is greater than 85 on Tuesday, and that also is incorrect. All right, so let's look at C, the range. Okay, so the range is going to be the difference between the lowest and the highest. So the lowest is going to be 30 on Monday. The lowest is going to be 20 on Tuesday. And so the difference is going to be 55 is the range here. That's going to be 65 is the range here. So the range of the typing speed on Monday is equal. No, 55 does not equal 65. So let's hope it's D. All right, so we've got the interquartile range. What is the interquartile range? Well, you see between quartile 1 and 2, you've got the edge of the box. And so that's going to be 55. And we've got the other edge of the box between 3 and 4. That's going to be 80. And if you take the difference between those, that's an interquartile range of 25, because we're looking at the range, or the difference between the two edges of the box. So that's the interquartile range. So let's see, we've got a 50 right here, and then we've got a 75 right here. So 50 minus 75, that's also 25. And it says that the interquartile range of the type speed on Monday is equal to the interquartile range of the typing speeds on Tuesday, equal 25, is equal to 25. So our answer here is D. Let's see how we did across the state of Texas. So this is right in the middle of the difficulty, tied for the 18th most difficult on a 38 question test. And we see that only 43% of our students were able to get this correct. Now, what is it that's kind of interesting about A, B, or C that might have taken some of the students kind of off guard here? Well, you notice we have a lot of vocabulary. So we need median, we need maximum, we need range. And quite honestly, probably the most recognizable term there is maximum. Even though Monday wasn't greater than Tuesday, they were equal, right? I think one of the draws to B is that we at least recognize what that word maximum is, because you have to know the median means the middle, right? The range is going to be the difference. And then quite honestly, the interquartile range, the IQR, is definitely one that involves the most amount of new vocabulary there, because that is definitely new to this to these students here. So probably for this particular problem, what teachers need to focus on is vocab. And just like we do with this problem, rather than looking at a data set and just finding one thing, we need to calculate everything. So get a data set just like we do here and calculate the median, calculate the maximum, the range of each, the interquartile range. Just do everything with a data set rather than just looking for one isolated thing like the median or the interquartile range. For number 11, we are describing pi. This is TEKS 7.5b, reporting category 3. So we just need to find the definition of pi. Well, let's look at our reference materials. What do we know about pi? Pi shows up in the circumference of a circle, and we see pi showing up down there in the equivalency of 3.14, or we've got this, this ratio of 22/7. And that's basically all we have here. But what's going to be most important for us is this right here. The circumference equals pi over diameter. We can use that. So let's figure this out. Circumference equals pi over diameter. Now, how is that helpful? Well, if we take a circle, right, and we want to find their circumference, so that's kind of like the perimeter going all the way around, what you could do is you can multiply the diameter, right? This is your diameter right here, by this strange Greek letter called pi, which is about 3.14. It's actually an irrational number that never stops. So why could you multiply that? Well, what happens if we use our properties of operations to isolate pi? What do we do? Well, if we want to isolate pi, since pi is being multiplied by the diameter, let's go ahead and divide by the diameter. So if we divide pi times diameter by diameter, the two diameters will cancel each other out, and you just get pi by itself. In order to do that, though, we need to divide both sides by the diameter to keep it a balanced equation. So pi is a ratio. This 3.14 is a ratio of the circumference over the diameter. And so this is what was discovered thousands of years ago, that any circle, whether it's really small like this, or whether it's much larger, if you take the circumference and you divide it by the diameter, you're always going to get the same magic ratio. That's about 3.14. And so thinking of it as a ratio there, let's take a look at this. The circumference, the pi is the ratio of the circumference to its diameter. So pi equals the circumference to its diameter. Well, that's what we just said. So let's check the other ones to make sure they're incorrect. The ratio of the circumference to its radius. No, it's not this. It's over the diameter. The radius of a circle times 2 times 3.14. That's radius times 2 times pi. That's, if you notice right here, we actually saw that. 2 pi r, that's actually this circumference right here. So that's the circumference, but that doesn't necessarily help us with pi. That just tells us how to find the circumference if you have pi. And the diameter of a circle times 2 times 3.14. Well, that doesn't make sense. That's not anything. That's kind of like the previous one, but it's using the d rather than the r, which we don't need. So the answer here is A, the ratio of the circumference of a circle to its diameter. Let's see how we did across the state of Texas. So this was the 11th most difficult. You notice we had almost as many people choose this C as they did the correct answer A. Remember the C was actually something that they could find on the formula chart, right? They could find the circumference equals 2 pi r, which is what this is doing, right? 2 times the radius times the 3.14. So they at least recognize that. This is a difficult problem simply because it's pure definition. There's not even really any calculation that needs to happen. We need to know what pi is. And a lot of times when we as educators are introducing pi to our students, we might talk about the fact that it is a ratio, but for the most part, students just remember, oh yeah, pi. That's that number or that symbol on my calculator that gives me the 3.1415, and it goes on and on and on and on. So we need to, as educators, make sure that when we are discussing pi, we are also saying pi is not only equivalent to about 3.14, but it's also the ratio, and then just use this definition, the ratio of the circumference to the diameter. And if we can get that into our vocabulary definition, pi is the ratio of the circumference to the diameter, the circumference of a circle to its diameter, however you want to phrase it. If we can put that into our lexicon so that every time we reference pi, we're constantly bringing that up to students. Remember, what is pi? It's the ratio of the circumference of a circle to its diameter. They will at least remember it's a ratio. And then if obviously we can show them how to derive it from what we do have on the circumference by dividing both sides by d, that's also a good clue, but they just simply need to remember that it's a ratio and not just equate it with that 3.14. For number 12, we are solving graphs. This is a readiness standard in reporting category 4, TX 7.6G. So it looks like a pretty simple bar graph, but look at what we're asked to do here. We need to find car brands that represent 60% of the sales. So first, what we need to do is label this. So brand A is 18, brand B is 15, brand C is 21. That's not that difficult. 6. We need to add these up here to see what's the total sales. 21 and 6. Right, so that's 13. 14, that's 20. 2, 4, 5, 6. All right, so 60. So 60 total sales. And we need to find 60% of that. So how do you find 60% of 60? Well, let's know that we're going to be multiplying. And we don't really multiply percents. We could make a proportion, or we could realize that 60%, right, is equal to the fraction 60 over 100, because any percent is just that number over 100, which equals 6/10 or 0.6. All right, so let's just multiply 60 times 0.6, which is equivalent to 60%. What you're going to get is 36. Now we've got one digit behind the decimal in the factor, so we need one digit behind the decimal, so we need 36. So that's all we're looking for. We're looking for two of these that add up to 36. So let's look at brand A and B, right? 18 and 15, right? That is going to equal 33. Close. Brand A and C, 18 and 21, right? That is going to be 39. Too high. Brand B and C is 15, 21. That's the 36 we're looking for. And let's see, what is our bottom two there? Okay, we've got our C and D. And let's see, C is 21 and 6, so just not quite enough. 21 plus 6, that equals 27. So we're looking for our 36. Our answer here is C. And let's see how we did across the state of Texas. So this was tied for the 8th most difficult, and I kept all the calculations up here to show you that you see B was actually chosen more than the correct answer of C. But if we really got down to, the 60% of 60 looking for 36, I really don't think that if students knew they were looking for 36, they were going to miscalculate 18 and 21, because 18 and 21 obviously don't make 36. If they made it this far, I think it became very simple. My thinking here is, let's just take a look at the problem itself. If I'm not sure what to do as a student, and I don't know how to calculate this, probably the most attractive thing is for me to choose the two highest bars, A and C. So most likely, we had the highest percentage of students choosing B, A, and C simply because, this is my own thought, they had no idea what to do, and they just chose the highest two bars. So what we need to do as educators here is really practice these types of problems, the multiple steps of first finding the total, how to find a percentage of that total by converting it to a decimal and multiplying. You could use a proportion as well, because if you could do these two steps, finding 36 is not that difficult. I don't think that was the problem. I think it was getting to that 36. That was the issue. For number 13, we are looking at the area of composite figures. This is a readiness standard, TEAC 7.9C in reporting category 3. So you see we have two trapezoids here, and we need to simply find the area, but we do have the equation editor down there, so there's no A, B, C, or D to choose from. We've just got to figure it out. And though they look similar, these two trapezoids are slightly different, right? We notice that we've got similar heights here, but we've got a base of 4 and a base of 5. So let's keep that in mind as we look at our reference material here. area. How do we find the area of a trapezoid? So we see it right around here. We've got this 1/2 base 1 plus base 2 times height. So let's copy that down. So we've got A equals 1/2 base 1 plus base 2 times your height. So let's do this first one up here first. So we've got a base 1 of, let's call that 4. We got a base 2 of this 3. Height. Sometimes in a regular trapezoid, you can't use the side length, right? If it's a regular trapezoid that we're used to seeing, we're going to need some type of height given to us. But since it's a right angle, we can actually use this side length as my height. So that's going to be 2. So let's see, I've got 1/2 times 7 times 2. So that's going to be 1/2 of 14. And that's simply going to be 7. All right, so this is 7 square feet. Let's do the same thing for that bottom one, realizing we're going to get a slightly larger number just because we've got a different base there that's a little bit bigger than the other one. So area equals 1/2. We need to copy this whole thing down. Base sub 1, base sub 2 times the height. So I've got 1/2, and then I've got 3 and 5. So 3 plus 5, that's going to be 8. Then we're going to multiply that by same height there, and that's going to be 2. So that's going to equal 1/2 times 8 times 2. So that's 1/2 of 16, right? So that's going to be 8. Now, my answer is not 7. My answer is not 8. My answer is 7 plus this 8, which means it's simply 15. But that was a whole lot of work to get to that 15. So let's see how we did across the state of Texas. So this number, 13, is tied with number 12 as the 8th most difficult. You see, we only have 32% of our students getting it correct, and I can see why. The area formula for trapezoid is itself a little bit complicated, right? So you've got to grab two bases, the height, and multiply that by 1/2. So there's a lot of error opportunities there. Then you've got to do the same thing down here. So I could easily see a situation in which a student got 7, right? Or a student got 8 and then answered one of those two answers. Put those in there rather than adding them up. So this is one in which we just need lots of practice with trapezoids. I think students are a little bit more familiar with how to find the area of a triangle, right? The area equals 1/2 base times height. They've been doing rectangles for a long time, right? Just base times height. But it's this trapezoid that is a little bit tricky. So students need extra practice with trapezoids, and then adding on top of that, you add that composite figure. So having two different trapezoids you need to add together, plus the fact that there was no A, B, C, or D to choose your answers from, made it difficult. For number 14, we are looking at operational word problems. This is a readiness standard in reporting category 2, TEKS 7.3b. So we have a fabric store. We've got two rolls. One roll has got 10 and 7/8. The other roll's got 12 and a quarter. They sell 4 pieces of cloth. Each of the sold pieces of cloth are 4 3/8. We need to find how much we have left. Well, we're going to have to do a little bit of addition, a little bit of subtraction, and they're mixed numbers, and we need to find a common denominator. So let's draw a representation first. So I've got one roll. Okay, so I'm going to draw a roll right here. Now I'm going to say it's 10 and 7/8. Okay, they're of the same cloth, so that means I'm going to add these two. The other roll is 12 and a quarter. Okay, so I'm going to do this. 12 and 1/4 cloth. So my first question is, how much actual cloth do I have? Well, I need to add those two. In order to do that, I need same denominator. So looking at my 8, looking at my 4, you know what, if I double the 1/4, I'm going to get 12 and 1/4. I'm just going to double it to 12 and 2/8, right? So now I can add the 10 and 7/8. You could just add that vertically, right? So 12 and 10 make your 22. 2/8, 7/8 makes 9/8. Now this is where it gets a little bit tricky. If we want to, we could take an 8/8 out. That's a whole thing. we can add that as an extra whole there. We can say that's 23 and an eighth. So 22 and 9/8 is the same as 23 and 1/8. I'm going to keep that 22 and 9/8 because in case I need to borrow or regroup here, it might be a little bit easier to have that 9/8 up there. So 22 and 9/8. Now I'm taking 4 pieces of cloth, right? So I'm going to take away 1, 2, 3, 4. These are not supposed to be proportional. They're 4 and 3/8 each. And then my question is, how much is left? What's my leftover? So I've got my 4 and 3/8. What's left over? All right, well, let's see what the 4 and 3/8 makes. And then I'll just take that away from 22 and 9/8. Okay, so 4 and 3/8 times 4. What I'm going to do is I'm going to use the distributive property. I'm going to break this up into 4 times 4, and then the 4 times the 3/8. I'm just going to multiply those separately. 4 times 3/8. Simply because 4 times 4, right, is going to be easy. That's 16. Now 4 times 3/8, that means I got 3/8 plus 3/8 plus 3/8 plus 3/8. So you see I'm just going to multiply my 4 times my numerator. That's going to be 12/8. So I've got 16 and 12/8. Same thing. Not very useful. So I'm going to take a whole out of that. So I'm going to take an 8/8 away. I'm going to regroup that as a 1. So that's going to leave me with 17 wholes and 4/8 left over. So now I can do a little bit of subtraction, and I'm glad I kept that 9/8. That's going to be helpful. So if I've got 22 and 9/8, and I'm going to take away 17 and 4/8, right? Let's just subtract. As long as our numerator on the top is larger, we can go ahead and subtract just like this. 9/8 minus 4/8 is 5/8. 22 minus 17 is 5. 5 and 5/8. Our answer here is going to be that B. Let's see how we did across the state of Texas. So this was the 19th easiest, right in the middle of a 38 question test. We see we got 44% of our students getting it right, so less than 50. Now here's the interesting thing, is this particular question had C as an answer choice that was the second most chosen. Almost a quarter of the students chose C rather than the correct answer B. So what is it about C that caused an error? Well, remember we had as our total of these two right here, 22 and 9/8, right? Or you can, view it as 23 and 1/8, either way. And if we have this 4 and 3/8, remember we multiplied this. Well, what happens if students multiply this 4 times the 4 and 3/8, but they mess up on the multiplication, right? So they multiply the 4 times 4, the whole numbers, right? But then they end up adding the 4 and the 3 rather than multiplying the 4 and the 3. Well, that's going to get you 16 and 7/8. And then if you subtract the two, 16 and 7/8, guess what you're going to get? You're going to get 22 minus 16 is 6. 9/8 minus 7/8 is 2/8, which reduces to 6 and 1/4. So students that chose C most likely at least added these correctly, right? They found the common denominator, they added those. The issue became, how do we multiply a whole number by a mixed number? So that is probably something that we could use a little bit of extra practice on, right? If you set it up like that, it still looks a little bit weird. You have to multiply the whole numbers together, but then you also have to multiply the whole number by the fraction. And multiplying a whole number by a fraction can be a little bit difficult, right? You can always turn any whole number into a fraction, and you can just see it as 12/8, or you could really just view it as repeated addition if that's going to help you. You got 4 sets of 3/8, and if you add those together, obviously we're not adding the denominators, just the numerators. So I think for many students, the issue was not adding these, it was multiplying 4 times the 4 and 3/8. For number 15, we are looking at predictions from simple experiments. This is a reporting category 1 readiness standard, TEKS 7.6H. Pretty simple. We've got a spinner here. We've got 8 sections, and we've got a diamond, star, or triangle. We simply need to figure out which of these statements about spinning it is true. This is a simple experiment, right? Because this is a simple event. You can only get one response rather than a compound event where you have to spin it twice and get like a series of items. So this is going to be pretty simple for us to figure out. Let's just go ahead and put a little bit of fractions here to help us here. Diamonds, right? I've got 1, 2, 3, 4. So let's call that 4/8. Stars, I've got 1, 2, 3, 3/8. All right, and then your triangle, 1/8. So you're most likely to pick your diamond, least likely to pick your triangle. So you're more likely to land on a diamond than a star. Well, yes, because you've got 4/8 is more likely than a 3/8. So that already looks good. Let's check the other three to make sure they're wrong. Equally likely to land on a triangle, star, or diamond. Yeah, so they're wanting you to think that a triangle, 1/8, is equal to a star, 3/8, is equal to a diamond, 4/8. That is a no. 4 times as likely to land on a diamond than a star. All right, so 4/8 equals 4 times, what is a star? 4 times a star, 3/8. Nope, that's not going to work. Now, here's the interesting thing. If they would have said triangle, we actually would have been correct. If you would have said triangle, 4/8 is 4 times 1/8. So that's incorrect. Less likely to land on a diamond. So diamond is less likely than a star, 3/8. Right, we know that is incorrect. All right, so our answer here is A, and let's see how we did across the state of Texas. As you would imagine, this was very easy. This actually was the third easiest on the entire test. Look at that, 72% of our students actually got that correct. And the one that tripped them up the most, right, is going to be this C that we were looking at. This is 4 times as likely. If this had said not a star but a triangle, it would have been correct. Other than that, it was pretty simple for many of our students. So good job for them and good job for us as a state. Number 16, we are sticking with probabilities, this time simple and compound probabilities, another readiness standard in reporting category 1, 7.6i. So we have an 8-face geometric solid, basically a die, is being used, and we have all of these rows categorized for us, right? And as we can see, we've got 3 rows of 10, so that's where our 30 rows comes in. So this is 3, this is 10, right? So the results are shown. So based on these results, what is the experimental probability? All right, so that means we're going to use not what should theoretically happen, because you've got 8 equal faces, but based on what has happened in the past, we're going to use this data to predict the next time something is rolled, it will land with a 7. Okay, so what we do here is we figure out what is our probability. So we need our total, and then the number of sevens, right? So that's going to be our experimental probability. And so how many sevens do we have? Well, there's a lot of numbers here, so you want to kind of go slow to make sure you don't miss anything. I've got 1 there. I've got 1 there. That's it. I've only got 2 sevens out of, they already gave us 30, right? It's a 3 by 10 array. So I don't see 2 out of 30, but it is a fraction. Let's go and simplify it. That's it. 1 out of 15. And so my answer here is D. Let's see how we did across the state of Texas. So this was the 18th easiest, right in the middle of the pack. Less than half of our students got it correct. So how did we get this wrong? Well, if we take a look at this 4/15, if a student really doesn't know what to do, right, you can just grab some random numbers, right? So the number of faces over the number of times that the die was rolled, right? And you can simplify that to 4/15. So this students that chose A probably didn't really understand how to set up probability with the total versus the number of sevens. They just did the total with the amount of faces there are. Okay, so this 1/8 doesn't surprise me is the most chosen incorrect answer because this is your theoretical probability. So there's a difference between the theoretical probability and the experimental probability. We're looking for the experimental probability. The theoretical probability is if we hadn't rolled anything, how many faces are there? Well, there's 8 faces. How many sevens are there going to be on that? Well, assuming it's numbered 1 to 8, there's only 1 7 out of 8 faces. So that's your theoretical probability. But we wanted to make a prediction based off the experimental probability of what actually happened. And in that case, right, it's only going to be that 2 out of that 30 or that 1 out of 15. Now, if we get this 1 out of 4, right, this most likely means the students found the two sevens, but then instead of using the 30 as their denominator, they use that 8 as their denominator, the number of faces, and that gets you your 1/4. So we just have some misconceptions here, and this would be a good opportunity for students to practice with the same data set, finding both the theoretical and the experimental to see how they differ. For number 17, we are looking at volume, a readiness standard, TEAC 7.9a, reporting category 3. So we have a square pyramid, we've got the side length, the height, simply need to find the volume. So let's draw a visual representation so we've got something to kind of look at. So I'm going to try to draw a square-based pyramid. It might not be perfect, right? But we can at least kind of get something working here. Right, and so, all right, there we go. It's not perfect, but it works. So we got a side length, the base is 7, right? So it's a square. So that's 7, that's 7, it's 7 all the way around, right? And we've got this height, so that's the one that it's kind of hard to visually represent. It goes right down to the middle of the base, and it's not an actual slanted side. It's actually just kind of an invisible line that doesn't really exist within that pyramid, but we need that to find the height, right? 6.6 feet. What we don't need are any of these, what we call slant heights, right? Like this line right here, we don't need that because it's slanted. We want this imaginary line that is going to be 90 degrees perpendicular to the base and reaching up to the vertex. So we've got our visual representation. Let's figure out how we find the volume of a pyramid. There we go, 1/3 base times height. We see that right there. All right, so 1/3 base times height. So my volume equals 1/3 base times height. So I'm going to substitute in my base. Now this base is actually the area of the base. So I need to find the area of the base. That's a square. So 7 times 7, that's 49. So I'm going to say 49 times this 6.6. So that's going to be a little bit of calculation here, but you know what? I want to go ahead and do this 1/3 times this 6.6 because I see that that's basically the same as taking your 6.6, dividing it by 3. Look how easily that goes in, right? That's going to be 2.2. So I just need 2.2 times 49. And that's because that's going to be my 2.2. And then I just need to multiply that by that 49. So that's going to be 18. That's 8. That's 9. And then that's going to be 18, right? And that's 8. That's 9 again. So 98. 98. All right, so that's going to be 17. So I've got this 1078, but I've got 1 digit behind the decimal in the factor, so I need 1 digit behind the decimal. My product, 107.8. There we go. Our answer is A. Let's see how we did across the state of Texas. So this was the 16th most difficult. You see, we didn't even get 40% of our students getting it correct. All right, so to go back to our pyramid here, how do we get B, this 101.64? Well, this would come if students misplaced these two. If they said the side length was this 6.6, which is actually the height, right? If you do the side length is 6.6, and then you do the height as 7, right? Then you're going to get this volume equals that 1/3, the base, which is the 6.6 squared, right, times the height of 7. That actually gets you, first off, that's going to take a whole lot of work, but that will get you that 101.64. So just mislabeling it. How do we get this C? Well, let's say that they actually labeled it correctly, right? So we got the 7 here, we got the 7 here, and we know that this is the 6.6, but they simply copied down the wrong formula. They replaced the 1/3 with the 1/2, right? And then you get this 49 times 6.6. So you get the base and the height correct. They just simply did 1/3 and they replaced it with 1/2. That's how you get this C. So we've got a few errors here for students, and we just need extra practice on number 1, drawing a representation so that we can correctly label the sides in order to find the base, because most of the time when we're dealing with the base, right, you're not going to get the area of the base. They're going to give you the side lengths. You're going to have to calculate that area. The height is a little bit easier, but you have to do a little bit of calculation there. We need some extra practice with that to make sure we set up the proper equation. For number 18, we are looking at equations and inequalities. This is a readiness standard, TEKS 7.11a, in reporting category 2. So we just need to find which of these is not in the solution set of this inequality, and we need to isolate that x. So what do we have here? Well, first off, we've got negative 5x plus 4x, right? So if I've got these, let's say these are negative x's, right? I'm going to make that negative be red. And let's say I've got positive here. So I've got 4 positive, right? You see we're going to cancel these ones out, except I'm going to be left with this 1x that's left over, and it's a negative. Right, so negative 5x plus 4x equals negative x. Think of it on a number line, right? You've got negative 5 right over here, and I'm going over to a jump of 4. That's a plus 4. That still leaves me with a negative 1x, or just a negative x. So negative x plus this 4 is greater than or less than or equal to 12, right? So we're going to subtract 4 from both sides. So we want to isolate that x. Negative x is less than or equal to 8, but we don't want a negative x, right? So we want a positive x. How do we do that? Well, we can either divide or multiply by negative 1. It's not going to change the coefficient, but it is going to change the sign. So negative 1 times negative 1 makes x. And then this is going to be a negative 8. But what happens when we multiply or divide by a negative? It actually flips the inequality. So it's going to be x is greater than or equal to negative 8. So what is greater than or equal to negative 8? Well, let me extend this out here, right here. Right, I've got my negative 8. I've got my negative 7. I've got my negative 6. So all of these right here are going to be equal to or greater than that negative 8. What is the one that is left alone? It's this b. Negative 9 is actually less than your negative 8. Too small. So our answer here is B. Let's see how we did across the state of Texas. So this was the 13th most difficult problem. And as you probably would expect, right, the most chosen incorrect answer was going to be this negative 6. Really, you could have eliminated A and D just with basic logic. If you're looking at which one is not in the solution set, and you have 4 numbers, they're not given to you consecutively, right? But negative 6, negative 7, negative 8, negative 9, right? If you rearrange them, you know it's not going to be either of those, right? It's going to have to be one or the other. So it is going to have to be this negative 6 or negative 9. And really, we could have gotten this all the way correct, right? X is greater than or equal to this negative 8. And then just simply not really been sure of this. What does that mean to be greater than or equal to negative 8? That's why I always draw a number line when we're dealing with negatives, just because it could be confusing, right? Because you think of this 6. Well, 6, right, might not necessarily fit that. But if you think of that negative 6, right, sometimes the difficulty comes realizing that negative 6 actually is greater, right? Even though it's a smaller digit, right? So 6 is definitely smaller than 8. When we're dealing with negatives, right, the larger the digit, that means the farther away it is from 0. So recognizing that this negative 6 is actually closer to 0, which means it's greater than that negative 8, probably was the misconception there, and not realizing what that negative does to that 6 smaller digit, but makes it closer to 0. For number 19, we are looking at attributes of similarity. This is TEK 7.5a, reporting category 3. We need to find 2 correct answers describing a pair of quadrilaterals that are similar. Now, we need to understand what this term means, right? So similar means they are proportional. And so there are some things that are going to be the same, and then some things are just going to be similar. So pair of quadrilaterals, let's do this. Let's just draw a right trapezoid here, and then to make it similar, right, we'll try to make it proportional to where it's, Everything's the same except it's obviously the scale's a little bit bigger, right? So let's take a look at our answers here. The corresponding sides of the quadrilaterals must be congruent. Now they can be congruent, but it's this must, right? Congruent means same size and then same shape. And as you can see, these are similar quadrilaterals, but we don't have the same size. They're proportional, so it's not going to be that one. The opposite sides of the quadrilaterals must be congruent. No, definitely. And we're looking at that, and then that doesn't make any sense. So this must be congruent is going to be a problem. Similar shapes can be congruent if I guess if you really want to think about it, but they don't have to be. Now, the corresponding angles, that's different. Take a look at these angles, right? So, right, we've got a right angle, we've got a right angle. We got another right angle and another right angle. See how they're congruent, right? And then you've got an obtuse angle up here. It's the exact same obtuse angle right there, and two acute angles. So you do have corresponding angles that are congruent, just not corresponding sides. The corresponding angles of the quadrilaterals must be right angles each. That's the problem. I've got two right angles, but I've got two that are not. I could have drawn, a parallelogram, and we could have been fine. So you could have had no right angles. So the fifth one, hopefully, is it. The side lengths must be proportional. There we go. Yep, we can have proportional side lengths here, right? If we wanted to make a proportion, we have this vertical side. It's proportional to that vertical side. We can compare it to like the two bases, and we'd be good. So it's going to be that third and that fifth option as our correct answers. Let's see how we did across the state of Texas. So this was the second most difficult problem, assuming that we are counting the correct answer as getting full credit or both points, right? We do have 54% getting 1 point, and then we had 33% getting 0 points. I think the big difficulty here is basic vocabulary. What is a similar quadrilateral? What is a congruent quadrilateral? I think most students were probably able to figure out corresponding sides, opposite sides, though there might have been a little bit of confusion between corresponding and opposite. They're still just looking at the sides, but it's the fact that we're dealing with proportionality, similarity, and congruence. This is a problem that relies heavily on vocabulary. So this is something in which we need to give students extra practice on describing verbally how quadrilaterals or any type of shapes are similar, congruent, proportional, using that language rather than always just doing, the visual representation here and then using numbers, right, to create some type of proportion, right? We're used to doing this, but do we just describe how these are proportional or congruent with words rather than simply always relying on, making the actual proportions like this? For number 20, we are comparing two populations. This is TEKS 7.12c in reporting category 4, basic double bar graph, college X, college Y. And then we have an inference here that we need to find is best supported. So let's just quickly kind of summarize what we have here. Right, so we've got 8, college X, right, has got 8, 3, and 2. We can use blue for college Y. That's going to be 4, 7, and then 9. All right, so let's see what we got here. There are more students who attend college X than students who attend college Y. I don't think you're going to find a college, right? College X has represented here 13, and then college Y has that's 11, that's 20. So just because there were more students surveyed, I don't think that we can say that there's more students at one than the other. Do you see how they're randomly selected students? Yeah, so A is not going to work for us. That's just a random sampling. Let's look at B. The mode, time preference for studying among students who attend college Y is in the morning. So mode means most chosen. And we're looking for college X, so that's going to be red. And college X, yeah, that 8 is definitely the most, so that's looking pretty good. Let's check C and D to make sure they're wrong. More students who attend college Y like to study in the evening than in the morning and afternoon combined. Well, that's going to be very easy to figure out. College Y, I like to study in the evening. Okay, so your evening is 9. Is more than, so that's going to be greater than morning and afternoon combined. So your morning is 4, and your afternoon is 7 combined. That's 9 is greater than 11. Yeah, that's not going to work. D, the percentage of students who prefer studying in the morning or afternoon is equal for students attending college X or Y. Okay, so the percentage of students who prefer studying in the morning or afternoon. All right, so let's figure out for each college here, right? So morning and afternoon is going to be 8 plus 3 out of what's the total? 13. So that's going to be 11 out of 13, right? So they're saying that this is going to be equal, then we've got this for college Y, the 4 plus 7 over, there's 20 total, so that's 11 over 20. Take a look at this. We don't even have to find a common denominator. Look, we've got the same numerator, and the fact that they have different denominators means they are not equal. So D is incorrect. Our answer here is B, the mode. Let's see how we did across the state of Texas. So as you could probably guess, this did tend to be on the easier side. This was tied for the 11th easiest. We had over half of our students getting it correct. Not many students chose A. I'm thinking what made C and D a little bit confusing for students is just think about the calculations, especially D. That was quite a bit of calculations. So sometimes if we're not sure what this mode means and we haven't just easily identified that, if that vocabulary word is too difficult, we're just going to kind of guess, because rather than doing the actual calculations, right, we're having to combine, we're having to find percentages. Sometimes students just kind of eyeball it. So the key here is twofold. Number one, making sure that students really have a firm grasp on, the mode, the median, the range. They have grasp of all of those definitions that we'll see here with these graphs. But secondly, take the time to actually calculate these rather than just eyeballing them. Because even if they didn't know what mode was, they'd already eliminated A. If they had calculated C and D, they could have eliminated that and then just chosen B just by process of elimination. For number 21, we are solving rate problems. This is a readiness standard, TEAC 7.4D, in reporting category 2. So we have a musician that is wanting to buy some sound equipment. We're saving some money here, already saved $750, and is going to save $130 every month for the next 12 months, not spend any money that he saves, okay, until he can afford the equipment. But we're looking for a percentage increase, all right, from the original amount of money. Well, how much did he originally save? He saved $750. How much did he save at the end of the 12 months? Well, we need to take that $130 a month, right? And we need to multiply that by 12, right? So that is going to be, let's just do it like this here, right? So that's going to be 260, right? 130. That's going to be 1560. So that's the amount he saved. Plus he had this, original 750. So how do we find percentage increase? So when we're looking for a percent increase, it is just going to be a basic ratio that we can use division to solve, right? Our numerator is going to be the amount increased, and then we're going to divide that by the original amount. So what is our amount increased? Well, we've got the 1560. That's how much he saved over the 12 months. And then 750 was the original. All right, so let's just divide that. 750 into 1560. So let me see, 750, if I double that, that's going to be 1500. So that's going to go in twice, right? And that's 1500. And that's going to be really, really close. I need to add a decimal to go and continue. 750 does not go into 700. So let's add another 0. It will go in. 75 goes into 600 8 times, right? So 750 is times 8 is going to be that 6,000. And that's going to be your 6,000. There we go. So 2.08. Now that's a decimal. In order to turn that into percent, right, what do? We just multiply it by 100. Move the decimal over twice, 208%. So our answer here is C. Let's see how we did across the state of Texas. So this was tied for the 13th most difficult. Take a look. We only had 38% of our students get it correct. And quite honestly, one of the most chosen incorrect answers was not too far behind. That's 68%. So how did we get 68%? Because that's nothing like 208%. Well, remember the amount saved was the 1560, right? Now, if you add that to the 750, right, to see how much money he has now, well, you would get this right here, this 2310. And then if you're not sure how to calculate percent increase, what you might do is you might think, well, I need to take this 1560, divide that by the total amount of money he has right now, and that roughly goes about 67.5, about 68%. So that's probably what students did there. So this definitely comes back to just helping students really understand how to find this percent increase, right? And just really understanding that it's a basic ratio of the amount increased, right? Same with decrease as well, over the original amount. And once we have that ratio in our mind, it's actually not that difficult to solve these problems. For number 22, we are looking at equations for geometry concepts. This is TEKS 7.11c in reporting category 3. So we have a perimeter of a rectangle. Let's go ahead and just draw a rectangle here. We can actually use the connect line feature to get us a nice rectangle. All right, so let's draw that. There we go. And the rectangle has a width of 4 and length of 2.5x. So we'll say my width here is 4 inches and my length is 2.5. We don't know what x is, inches. So we need to find an equation to find the value of x. Okay, well, the perimeter, right, all the way around, 32 inches. But what do we know about perimeter, right? It's not going to be on our reference material that fell off a year or two ago. We're not necessarily looking at perimeter formulas here, just area formulas for that geometric concept there. So we need to remember that perimeter equals, this is what we've had, double the length plus double the width, right? You double the length, you double the width of 4 inches, double the length of 2.5x, add it all together, you get your 32 inches, right? So let's do some substitution. We know our 32 inches is the perimeter, so that's going to be 32. And we know this length here is 2.5x. So 2 times 2.5x plus 2 times our width here of 4. All right, and then we just simplify, solve for x. So 32 equals, let's double this, that's going to be 5x plus 2 times 4 is 8. We need to subtract 8 from both sides, right? And we're going to get 24 equals 5x. But actually, we didn't even need to go that far. Look, I went one step too far. Rather than actually solving for x, they just want us to find the equation. That was right there. They put the 32 on the other side, and they swapped the 5x and the 8, but that's totally fine. Our answer here is B. Let's see how we did across the state of Texas. So this was the third most difficult. Take a look. This wasn't the first or second most chosen answer. This was the third most chosen answer. Only 1 out of every 5 students in the state of Texas got this correct. Let's look at A and C to see what made them so tricky. Well, remember we had our rectangle here, right? We had our 4, 2.5x. So what students most likely did here on A is they just added these two, right? They just grabbed those two and said those two together equal the perimeter of 32 because they remembered you have to add some of them. And it is a little bit more visually appealing because take a look. You've got all 3 of your numbers given to you in the problem lined up right there. Okay, that's also going to be the same thing for C, but rather than adding them like you should for perimeter, right, you multiply them, which is what we do for area. So this is area, this is not the full perimeter, this is half the perimeter. because you need to double it. And what makes B look so strange is because these numbers 8 and 5 show up, and it just is a little bit weird sometimes to see them when they're not over here in our problem set. So this is one that definitely threw our students off, and they didn't even need to do any calculations. They didn't even need to solve for x. They simply need to set up the equation. So this requires a lot of extra practice, whether it be equations for area of perimeter, area of a trapezoid, area of a triangle. We need to give students tons of opportunities to practice writing these equations out rather than always solving for them. For number 23, we are looking at constant rates of change. This is a readiness standard, TEKS 7.4a, in reporting category 2. So we've got a family making homemade pickles. They pack the pickles at a rate of 80 pickles per 5 jars. So that's going to be our rate right there. You see that word per? Gives us a nice clue we're dealing with a ratio here. So 80 pickles per or over 5 jars. So we just simply need to represent that. Okay? So which answer choice is best to represent that? Y pickles. Okay, so remember our constant of proportionality is going to be that second row there, that y over x, that's what equals k. All right, so let's see. So k equals y over x, and they say my pickles are my y, right? That is my dependent variable. That's 80. My jars, that is going to be my independent variable. That is my x. So there's my 5. Okay. And then so, I mean, if I really want to figure that out, that's going to be 16. But let's see if we can figure out what we have here. So look at A. So y equals blank x. Well, that m is going to be, or this can be my k for direct variation. If we're looking at slope-intercept form, we would call that our m, right, our slope. But either way, that's looking at our constant rate of change. And if we were to separate this right here, right, we could do this. We could say that 16 equals y over x. And if I wanted to separate out or isolate that y, right, we could multiply both sides by x. Right, that's going to cancel that out. That's going to be y equals 16x. Or the way they have it is, y on the left. That's going to work. That's what that constant of proportionality does for us. That's our rate of change. So that first option is good. Let's check the rest. We need 2 correct answers here. Well, if this first option is correct, this second option cannot be correct. So they're not going to invert it. These two things are not equal. So it's definitely not going to be that one. All right, let's put some numbers in here. Since we know that this is correct, let's just substitute in some numbers, right? So 6, I'm going to put y equals 16 times 6, right? And so I'm just going to substitute it then and see if I get 160. I don't think I am. That's going to be 36. That's 96. All right, so that's not that, which means by definition, it doesn't even matter if those other 2 are correct. All 3 need to be correct. All right, let's see what I have down here. I've got 2 different graphs that I need to use. This fourth option is weird because it has an x-intercept, right? It starts over there. It doesn't even, I'm used to a y-intercept, but not an x-intercept that's other than the origin. So that says if you have 3 jars equals 0 pickles is how that's reading. But honestly, no, if you had 3 jars, right, that'd be 48. Y equals 16x. So if I had 3 jars, that's 16 times 3, that's 48. So it's not that one. Let's hope it's our final one. All right, so I'm looking for a spot here that looks like it's right. There we go. Looks like it's right on the intersection of 2 lines. And there we go. I've got my 5 jars over my 80 pickles. So I've got my 80 pickles over my 5 jars. So the reason it's not between the lines is because it's, right, it's 16, and then it's 32, right, and then it's 48, and then that's going to be 64, and there's your 80. So it doesn't hit your scale of 10 evenly up until it gets up to 80, but that last one is correct. So those are my 2 answers. My first choice In my fifth choice, let's see how we did across the state of Texas. So this was tied for the 18th most difficult, right in the middle of a pack of a 38 question test. As you can see, we had 43% of our students get both of these uh, points on this particular item, and we had another 43 get 1 point. So you put those together, right, you've got 86% of your students getting at least 1 point. So it really wasn't that difficult. What really helped this one was obviously having the equation right at the very beginning. That made it easy to substitute. I think it would have been much more difficult if this wasn't one of our answer choices, right? Because then having to evaluate this homemade pickles in a table, that would have been a little bit more difficult. So this is one that we need to continue to practice on, especially taking a problem situation here. Right? A very simple problem situation, granted, and then representing it in both equation, both tabular form, and both and graphically as well. For number 24, we are looking at surface area. This is TEKS 7.9D, supporting category 3. So we have an equilateral triangular prism, and we have some dimensions shown. The height of each triangular base is approximately, they give that to you at 5.2. So here's the trick. We are looking for the surface area, but not the total surface area. Looking for the lateral surface area. So the lateral surface area does not include bases. So this is a triangular prism, which means the two bases are the two triangles. And if we want the lateral surface area, we're literally just looking at the faces, not including the bases. Total surface area includes all faces, including bases, which means we're just looking at the area of these three rectangles here, right? So we have the difficult part of trying to figure out what is this? Well, here is what is going to help us. If we have this, this length of 9, what is that width? Well, remember, it's an equilateral triangular prism. If it's equilateral triangular prism, that means the bases are going to be equilateral triangles. So if this is 6 centimeters, this is 6 centimeters, and then the base that we're looking for, which is going to also, right, serve as our width here, it's also 6 centimeters. So then this is going to be 9 times 6, that's 54 square centimeters. And that's going to be 54 square centimeters because these are congruent rectangles, and that's 54 square centimeters, right? And that's going to be 150 if I add up my tens. 4 is 12, right? That's going to be 162 square centimeters. My answer here is A. Let's see how we did across the state of Texas. So this was the seventh most difficult problem. As you probably guessed, there were quite a few things that students had to know before they were even able to be successful with this, like how do we find the lateral surface area, and how does that compare with total surface area, right? So that's going to be a trick for some of our students. And right, so if we have anyone choosing B, that 280.8, basically what we're doing here is we're just taking all three of our numbers. We're almost acting as if we're finding the volume, even though that wouldn't technically be the volume. Uh, and we're just multiplying, right? 6 times 9 times 5.2, right? That's going to get you your 280.8. Now, this is the one I was expecting to see a lot of students choose. That's the total surface area. So remember we had our 162, right? That's these three altogether. Then what you would need to do is you would need to add the two bases, right? So each base, if you find the area, has got 31.2, right? So then you just double that and you're going to get your 193.2. As you can see, our 54 here is just, that's what we came up with, right, for one of these rectangles. So the students just found one and then selected that as the answer. But even more than that, take a look at the distribution of the answer selections. 31, 27, 30. Honestly, if we took a little bit of these and put them down here, we would get something that's really indicative of just guessing. So there was something about this particular problem that really threw the students off. So this is definitely one we need to practice. Specifically, what if we asked students to find both, find the total and the lateral? with the same problem set so we can differentiate between the two. And I think what really messed some of them up was the fact that we had, now they were on different triangles. I get that, but we had no width here. And if you're not paying attention, right, you're going to use this height as the width. And so having to even read this and say equilateral triangle, that means all three sides are equal. That was an extra layer of complexity that might have made it difficult for some of our students to complete this problem. For number 25, we are looking at slope-intercept form. This is a readiness standard T7.7a in reporting category 2. So we have a basic table here, and we need to use this to create an equation that describes this. And hopefully we see that we have got a few blanks, but hopefully we see that we have this slope-intercept form, y equals mx plus b. Right, that's really what we're looking at here. So let's open this up. All right, so y equals mx plus b. So we need to find both the m and the b. Well, the b, right, that's going to be our y-intercept. So the y-intercept is the place where the graph crosses the y-axis when x equals 0. Sometimes we have to calculate that by hand, but take a look. They've already given you an x equals 0. So they've done the work for you. So if x is going to be 0, y is going to be -3. This is our b, or our y-intercept. Now, plus -3, that's going to end up being a -3. So we're going to go and just take this -3 and move it right there. That was easy. Let's look at this m, though. How do we find m? Remember, we've got our equation that we can use for slope, right? The change in y over the change in x. So we don't necessarily see that here, so we need to bring that in here. It's not one of our reference materials. So we find the slope. I say change in y over change in x. Sometimes we'll see it rise over run. Either way, it's going to end up being the same thing. So rise over run, change in y, that's the Greek letter delta, meaning change, change in x. Really, this is what we're doing. We're going to take two different y coordinates, subtract them, find the change. Two different x coordinates, subtract them, find the change. Doesn't matter which two. You could do any combinations. You're going to get the exact same. So let's make this easy on ourselves. All right, let's just choose these two. So I'm going to make this x sub 1, x sub 2, y sub 1, y sub 2. You just want to make sure that your 2's are together, your 1's are together. All right, so my y sub 2 is -3 minus my y sub 1 is -1. Let's see, my x sub 2 is 0 minus, and then my x sub 1 is -6. All right, so those two negatives are going to make a positive. So really, it's going to be something over 6. -3 plus 1, I'm moving closer to 0. That's going to be -2/6. So simplify that to -1/3. So here we go. And you could have done that with any combination of x's and y's, and you would have got that answer. So let's see how we did across the state of Texas. So this is it. This is the number one most difficult problem on the entire test. Didn't help that it was drag and drop. So we had 6 different options to choose from. Right, take a look at this. Only 12% of the students got full credit, and only 29% got partial credit. So even if we're looking at both of those together, right, that's about 41% of our students that got either 2 points or 1 point. What made this so difficult? Well, the drag and drop didn't help. But quite honestly, if we look at our standard, right, remember this is standard 7.7a. 7.7a does talk about, representing linear relationships using verbal descriptions, tables, which is what we have here, graphs, and equations that simplify to the form y equals mx plus b's, right? So we'll call this the slope-intercept form. But how much time do we as educators really spend talking about what that b means, what that m means, right? We spend a lot of time in 7th grade talking about y equals kx and talking about the constant of proportionality, but do we see that these kind of serve that same function? And how do we calculate m by itself? How do we calculate change in y over the change in x? Unless we have a lot of practice doing that, which is something they'll be doing ad nauseum in 8th grade. This is where a little vertical alignment would help, and knowing that this is something they'll have to be spending a lot of time doing in 8th grade, we can bring some of those concepts down and get them ready for that while fulfilling this 7th grade standard as well. For number 26, we are looking at the area of composite figures. This is a readiness standard, TEAC 7.9C, in reporting category 3. So we have a cutting board here. Looks like someone made it in shop class. We have light pieces and dark pieces. And one thing that is going to be important, they call it out very subtly here, but they're not going to give you many dimensions. But the light pieces are congruent, the dark pieces are congruent, so we don't have to worry about that. And when the combined area of the dark pieces, okay, so I don't have any measurements on any of my dark pieces. Okay, I do have the length here, the 39 inches, right? This is going to extend all the way over. But I don't know, what this is right here. So this is what I can do. I can find, right, the total area. So let's do this. Okay, so my area of my, composite figure, right? So I'm going to do that 29 times 39. And so let's just go ahead and multiply that out. 29 times 39, that's 81. That's going to be 18. That's 26. And that's 27. That's 6. That's 8. 13. That's 11. All right, so 11, 31 square inches. Now, what I can do here, since I don't know I don't know, this width of any of these dark pieces, which is what I'm looking for, since I know the whole thing is 1,131 inches, I can just subtract the light pieces, and I'd be left with whatever the combined area is of the dark pieces. So this is what I have here. So the area of this light piece is going to be this 39 times 3 3/4. To make my life easier, I'm just going to call that, so the area, I'm going to call this the light piece. I'm going to call that 3.75. So 39, right, times this 3.75. So let's multiply those. 3.75 times this 39 inches, right, that's 45. Right, that's going to be 63, 67. And that's 27, and that's 33. And then that's going to be 15, 21, 22. That's 9, that's 11. All right, now we have to remember that I need some digits behind the decimal here. So I've got 2 digits behind the decimal, 2 digits behind the decimal. How many of these white pieces are there? 1, 2, 3, 4, 5, 6. So if I need to find the area, the combined area of the light, it's going to be 39 times 3.75, all of that times 6, because there's 6 of them. So let's multiply that by 6. 30, that's 12, that's 15. That's 36, 37. That's 24, 27. And that's going to be 8. 2 digits behind the decimal, 2 digits behind the decimal. All right, so 877.50 is the combined area of the light, which means the area of the dark, right, is going to be those two subtracted. The total area minus my 877, and let's make a 0.0 out there. Let's subtract these two and figure it out. That's going to be 5. Let's see, that's 2, that's 10, that's 3. Geez, I'm going to have to regroup all of these, looks like. That's 5. That's going to be 2. So 253.5 inches squared. So we're going to scroll down there. We're going to see that as D. But take a look at, this B right here. This B, I bet, is going to be a popular incorrect answer because it is the area of the light, not the area of the dark. But our answer here is D. Let's see how we did across the state of Texas. So this was the 12th most difficult and I thought we'd see a lot of students picking this 877.5, but we didn't, which lets me know that once again, just like the previous one, if you take some of that 36 and spread it across, right? This answer distribution, when all four have semi-close, this lets me think that we have a lot of guessing going on. Because, I mean, think about what I just did to solve this problem. I'm the teacher, and I was even getting tired of doing that calculation. This has to do with stamina. Building our students' stamina, giving them problems like this, giving them the time to do it, and just to see what happens when they get to the end of it and that satisfaction of doing all of that work and finding their answer as one of the four answer choices, right? We need to help students practice, even if they can understand how to do it. Just the physical labor of multiplying and subtracting all of those numbers, it did take a lot of time. And obviously, every time you do any calculation, you increase the chances of error by the number of calculations you're asking them to do. But we need to help increase our students' stamina, and then also we need to make sure they conceptually know how to find, the dark pieces, combined area. But I think most of them probably understood how to do it. They just didn't really feel like completing all of it, or they got tired halfway through, or they made a mistake. They couldn't find where the mistake was, and they ended up having to eyeball it. Number 27, we are looking at inequalities on a number line. This is TEAC 7.10b, reporting category 2. So we need to simplify this inequality here, and we need to find which one best represents it on the number line, right? And you can probably guess, yes, we are going to have a negative coefficient in front of x. We are going to need to divide by a negative and flip that inequality. But first things first, right? Let's subtract 29 from both sides. Right, let's get the x by itself. So that's going to be negative 4x is greater than 19 minus 29, that's negative 10. Right, so now I need to divide both sides by negative 4. Right, so the negative 4's are going to cancel out. That's going to be an x. But remember, when you divide or multiply by a negative, you end up flipping this. So that's going to be less than. That's going to end up being positive, but it's going to be 10 fourths, 5 halves, 2 fifths. So x is less than 2 fifths. Right? So I've got positive 2 fifths right here. Then I just need to choose the direction. But since it is less than, right, then it's going to be C. Now, how do we verify this real quick? Well, look, 0 is in the answer set. So that's going to be easy. Let's just substitute in 0 for x just to double check. That's going to be 0 right there. Is 29 greater than 19? Yes. All right, so my answer here is C. Let's see how we did across the state of Texas. So this was the 6th most difficult problem. And you see, once again, probably getting tired of hearing it, this looks an awful lot like guessing. But what's interesting here is, look, if you got all the way to this 2.5, right, you weren't really messed up with the x is less than or x is greater than, because look, right, that's the most infrequently chosen incorrect answer. A and B are a little bit more chosen, and you see that's coming from this negative 2.5, right? So we had this, remember we had the negative 4x is greater than this negative 10. And so this error comes from students not knowing that when you need to isolate that variable, you can't just divide by 4. It looks like that's what students were doing there, and they were getting this x is either greater than or x is less than this negative 2.5. They never realized that you can't divide a negative by a positive and still get a positive, right? This would end up being this negative x. So this provides us an opportunity to continue to work with students on isolating variables and how do we, right, eliminate negative coefficients. You need to either multiply or divide by a negative number. For number 28, we are solving graphs. This is a Grade Standard, TEAC 7.6G, reporting category 4. You see it's a hotspot, so there are 5 choices. We need to select 3 correct answers. So let's evaluate this circle graph here. So what do we know about it? Because we need to basically get a percentage in each of these slots before we can even look at those answers. So we have a total of 50 Okay, so let's mark that. That's going to be important. So 50 total plants. The number of tomato plants is twice the number of bell pepper. All right, so my bell pepper is 16, right? So this is going to be, if I double that 16%, that's 32%. And then the number of cucumber plants is the same. Okay, that makes sense. Those did look like they were the same. And the remainder consists of squash. All right, so there's that 12%. So let's get percentages in these, and then we can put actual numbers in these. Right, so I want to add up these three right here. 12, 32, 16. Right, that's going to be 4, that's 10, that's 50, that's 60, right? So 60%. We need to split evenly between watermelon and cucumber, right? It's the same between my watermelon and my cucumber. So I'm going to take that extra 40%, right? Because I need to subtract it from 100. 100% is the whole thing. Take that 60 I just added, that's 40. Right? I want to cut that in half. That's going to end up being 20% each. So what I need here is I need to get actual numbers, right? Because I see, look at that first one. Tomato plants is 16, 18. So I've got percentages and numbers. So I need to go ahead and find some numbers. How do I find numbers? Well, let's see if I can figure out. Let's start with an easy one, right? So 20% of this 50, right? So I can multiply it if I make this into a decimal. So that's 0.2. So let's just multiply that. And that's going to be 10, right? We need that digit behind the decimal. So this is 10, right? That's 10, which means there's only 30 left. And obviously the tomato is going to be the biggest. Let's do that tomato, 32%. Move that over twice. That's 50 times 0.32. So that's going to be 100. And that's going to be 150. 2 digits behind the decimal here. So I've got 16. All right, so I've got 16 there. And then I just need squash and bell pepper. So you know what? I could figure out the bell pepper. Remember, I doubled the bell pepper to get up to the 32%. So if I doubled the bell pepper, I'd get up to my 16. So I'm going to take that, and that's going to be 8, right? Because it's twice as big. This is right here, twice the number. So that works for both percentages and real numbers. And then I could just see how many I have so far. I've got 28 and 16. And that's going to be 44 out of a total of 50. There we go. There's my 6. Okay. So now I can finally start answering some of these questions here. The number of tomato plants is 16. Yes, that is 1, because you see that right there. So let me go ahead and choose that. I need 3 correct answers. Total number of cucumber and bell pepper is 18. Let's see, cucumber is 10, bell pepper is 8. Yep, right there. So that is going to be 18. So that looks good. Cucumber and bell pepper is 18. So I just need one more. Let's see what we have. Over 50% of the plants are tomatoes and bell peppers. Let me see. So my tomatoes and bell peppers, right? I've got this 32% and I've got this 16%. If I add those together, that's going to be, oh, so close, 48%. And you can also see that's incorrect, right? Here's your straight line. If you try to draw it straight down, you see that the tomatoes and bell peppers don't quite reach it. So that's incorrect. Watermelon and cucumber combined are the 40%. Yes, we did figure that one out. Right, they're 20 each. So that looks good. Let's just make sure the last one is incorrect. Cucumbers are 26% of the plants. Nope, cucumbers are 20% of the plants. All right. So we've got our 3 correct answers, first, second, and fourth choices. Let's see how we did across the state of Texas. So this was the 4th most difficult problem. You see that only 1 out of every 4 students got full credit, both points. Now, if you start looking at how many students got partial credit, put those together, now we're looking at, at least 75%. So it was difficult to get full credit, 4th most difficult, but a lot of students were able to at least get some partial credit. Here's some of the issues. Right, this is really the only item right there that you can eyeball, looking to see whether tomatoes and bell peppers were 50. You can see that those two combined were a little bit less than 50 because they were adjacent. Didn't make up half the circle. Other than that, we have a lot of opportunities for errors as we are converting from decimals to percents and back. And quite honestly, this is one of those problems that really sometimes encourages students to just eyeball it because it doesn't look like it's that difficult. It looks like they provide you quite a bit of information. Now you can tell from the earlier explanation that there was quite a bit of math you had to do in order to put numbers in each of these slots here. But a lot of these students just need practice working it out because I would make an estimated guess here that some of our students didn't work it all the way out and they just tried to just kind of guesstimate it a little bit. For number 29, we are determining the validity of equations and inequalities. This is TEKS 7.11b in reporting category 2. So, looks pretty straightforward here. We just need to substitute in this -3 for x. So let's just substitute that in for all of these. So it's going to be 5, multiply that by -3 because I'm substituting in that -3 to the x. Right, so that's going to be -15 plus 1 equals 16. So -14, that's going one closer to 0, definitely does not equal 16. All right, so that's no for that one. Let's check B here. So 4, and then I'm going to multiply that by -3 minus 8 equals 12. So that's a -12, right? 4 and 3 is 12. Positive, negative, make a negative. Minus 8 equals 12. And so look, now we're starting with -12, going further to the left, that's -20. Definitely does not equal 12. Let's check our C. So -2 times -3 plus 9 equals -12. 3 and 2 is 6. Negative, negative makes a positive. 6 plus 9, yeah, that is not equaling -12. So let's hope it's D. 3 times a -3, -6, and -15. 3 times 3 is 9. Positive, negative, make it negative. There we go. Look, I got -9, and I'm moving further to the left because it's minusing. So that's going to go farther away from 0. That is -15. So D is my correct answer. Let's see how we did across the state of Texas. So we have a fairly easy problem, tied for the 14th easiest. We see we have over half our students getting D correct. Now, how students entered this incorrectly shows you some errors they might make when they're substituting, right? So A works if instead of substituting in -3, you substitute in 3, because you see how that is going to equal, right, 16. So substitution error there. Now, B is kind of interesting because what happens here is you take the 4x minus 8, and what happens is you combine those into a -4x. And then if you substitute in that -3 there, well, guess what? You are going to get 12. So this error comes here from not knowing that you can't simplify unlike terms, that you can only simplify like terms. So they try to combine that. And then this C here, this one's interesting because you take your -3. What they do is they just bring in this +9, right? And they kind of forget the order of operations. And you simplify that first, and you end up getting this +6. And there you go. And that's how you get that +12. So simple errors of not knowing the order of operations, combining unlike terms, and then just substituting in a 3 for -3. For number 30, we are looking at simple and compound probabilities. This is TEKS 7.6i, a readiness standard in reporting category 1. So we're making some deli sandwiches here, and it looks like we've got a few different options. Right, we've got a bread option, we've got a meat option, and then we've got a cheese option. Right, so this is a compound probability because there are more than one layers here. You've got 3 layers, or more than 2 layers, right? You've got 3 layers. You can get a bread and a different cheese and a different meat altogether. So we're looking for probability of someone choosing white bread, ham, and cheddar cheese. Okay, so I'm just going to just make a sample space here. So I'm going to choose my bread, right? And I'm going to say, I'm going to give some space here. White bread and wheat bread. All right, so let's change to blue here. Let's go to meat. So what are the different meat options, right? So I could do ham, turkey, and salami. I could do all of those with white bread, so that's 3 choices so far. And then with wheat bread, I can also have those same 3. Ham, turkey, salami. So if I look down at the second column, right now I've got 6 options because I've got 6 different words written down. But I'm not done yet. Now, let's get the cheese. 2 options, American and cheddar. So with my ham, I'm just going to put A-M-E-R, C-H-E-D. So with my ham, my white ham, I can have American and cheddar. With my white turkey, I can have American and cheddar. And with my salami and white bread, I can have American and cheddar. So 2, 4, 6. 6 options there. And I'm going to repeat those down here. So American and cheddar. There's another 2. Another American cheddar with my wheat turkey. And then another American cheddar. That's another 6. So add those 2 together, right? Total of 12 options. So what is the probability that this customer will pick up the white bread, ham, and cheddar? Well, there's my white bread. There's my ham. There's my cheddar option right there. It's 1 out of 6 and 6 make 12. So 1 out of 12. Our answer here is D. Let's see how we did across the state of Texas. So this was the 5th most difficult problem. You see, barely over a quarter chose it correct, and we had the same number of students, right? Choose C and D, and quite honestly, the most chosen incorrect answer here was this 37%, B. So where do these other fractions come from? Well, the way I showed you how to solve it was kind of a longer way. Another way we could have done is we could have said, well, if I'm looking for white bread, what are the chances of getting white bread? Right? 1 out of 2, because there's only 2 different breads. That's that first choice. What are the chances of getting ham? Well, there's 1 out of 3, because I've got 3 different meats there, and you see that's the most chosen. Don't know why that would be the most chosen. And then cheddar, right, would be 1 out of 2. So what we could have done is, right, you could have just multiplied all of these, right, straight across. 2 times 3 is 6, times another 2 is 12. That got you that answer. If you just happen to multiply a half and a third, right, then you probably get this. That's how you get this 1/6. So I'm really thinking that students probably didn't understand how to either set up the sample space, or they didn't understand this shortcut of just multiplying. And so we're just trying to eyeball it, and they all look like fractions. And so they weren't really sure which one. Maybe they chose the fact that there were 3 different categories, a bread, a meat, and a cheese. That probably speaks to why 1/3 is the most chosen. So we really need to take a little bit of extra time practicing students on what does it mean to create sample spaces and how do we solve these compound probabilities. For number 31, we are looking at operational word problems. This is a readiness standard, TEAC 7.3b, in reporting category 2. So we just have a little bit of a temperature problem here. Got the outside temp at 4 p.m. So we've got an 8 degrees Celsius, decreased by 2.5 each hour until 10. Right, so I'm going to just kind of draw a vertical number line to represent my thermometer, right, and I'll have time and temp, right, so at 4 p.m., and you see we are going to get into the negative, right? That's 8 degrees Celsius, so decrease 2.5, okay, each hour. All right, so I just need to go 5, and then 6, and so on until I get into my 10 p.m. And so that's going to be slightly tricky because I am going to subtract a decimal, but ultimately it's not going to be the most difficult in the world, as long as I just use a little bit of number sense here. All right, so let's just take away 2.5 degrees. So if I take 2 degrees away from 8, it's going to be 6, so that extra half degree is going to give me 5.5. Take away an extra, 2.5, it's going to be 3. 3 take away 2.5, it's going to be 0.5. Now this is where I get into my negatives, okay? So if I take away a half degree, right, that's going to give me back to 0, and then I'm going to be left with a -2. And then at this point, it's like we're adding. I'm taking a -2, subtracting 2.5. It's like I'm adding those two, right? So -4.5, and then another 2.5 away, that's going to be -7. So it does look like I've got the answer there. Another way to solve this, right, would just be you get a rate, 2.5, and you get each hour between 4 and 10. So the question is, how many hours are there between 4 and 10? 1, 2, 3, 4, 5, 6, right? So you could have done your 2.5 times 6, right? And that's going to be 15. And then you could have just done, all right, so 8 degrees is the start. You take away 15 because that's how many drops. It has 6 sets of 2.5, and that also gets you your -7. Answer is C. Let's see how we did across the state of Texas. So this was a little bit on the easier side, 15th easiest, right? You see we had more than half our students, a little bit more, get this correct. So how do we get some of these incorrect answer choices, right? So if students recognize that I got 2.5 degrees each hour and it's 6 hours, right? If you just do the 2.5 times 6, remember that was the 15, and they just stopped there. And they didn't necessarily subtract that from 8 degrees, and so they just ended up with -15, right? If we're really not sure what to do, we could, take this 8 degrees, take away 10 p.m. Don't know why we would do that. You could get that -2 right there. And also on this -4, right? Instead of multiplying by 2.5, for some reason you could have done there's 6 hours times, 2 degrees rather than 2.5 degrees. That would be 12. And then you just take your 8 degree start, your 12-degree drop, and you get your -4. But once again, that's also very strange to get. So I kind of get this A as an incorrect answer choice. I had, about 1 out of every 5 students get that one. But this just probably is an opportunity for students to practice visualizing this. You notice I drew that vertical line to kind of represent both my thermometer and my timeline. I think something like that would probably be a good tool for students to use rather than just trying to do the straight calculations like we do here and do some subtraction. Visualizing it, representing it always helps organize their thoughts. For number 32, we are comparing numeric data. This is reporting category 4, a readiness standard, TEAC 7.12a. We've got 2 different dot plots here, group 1, group 2, and we've got some drop downs. All right, so we've got 2 different answers we need to look at here. So this first one, the distribution for the data for both groups is either symmetrical or asymmetrical. So what does that mean when we're looking at that? Well, let's start with symmetrical, right? So symmetrical harkens back to what we learned in elementary school about lines of symmetry, right? So that means that you could draw a line, and I'll draw this one right here, about halfway down each graph, and it's even on both sides, right? So a symmetrical graph might look like one to where it kind of peaks in the middle, like this, right? You can have a kind of line of symmetry. Sometimes it's got a valley in the middle like this, another line of symmetry, or it might be like, just kind of doing that same wave. Either way, you could look at either side and it would be the same thing. And so take a look at this. That necessarily does not look symmetrical on group 1 because you've got this peak over here on the left side and you have this valley over here on the right side. And then this almost looks kind of symmetrical, but it doesn't quite hit it in half because you notice we've got this high point over here on the right in group 2 and a lower point on the left side. But we do have, those are good. We've got these 2 little valleys right there. So overall, they are not symmetrical. That's what asymmetrical means. So A is just a prefix that means not. So asymmetrical means not symmetrical. They're definitely not. Now, we need to look, secondly, as they both have the same median, mode, range. Okay, so let's look at those. Median. Okay, so that's going to be my middle number. So let's just count. So we're literally just going to circle the middle number here. So in group 1, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the middle of that is going to be number 8, right? Because I want, to have 7 and 7 on either side. That's 14. That eighth one is going to be the middle. Right, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's my median right there. It's 11.5. If the other median is 11.5, that's my answer. So I've got 1, 2, 3. I've got 7, 8, 9, 10, 11, 12, 13, 14, another 15. So I'm looking for 8, the eighth one. 1, 2, 3, 4, 5, 6, 7. Oh, not quite. Not the middle. All right, let's look at the mode. So the mode is just the most chosen, most popular. A little bit easier to calculate it because on this dot plot you literally look at the tallest one. So my mode here is 10.5. My mode here is 11.5. So that's not it. So then I need to calculate the range, right? And so that's the difference between the most and the least chosen. Doesn't matter how many times it was chosen. And take a look. They both go from 10.5 to 13.5, right? So that's a range of 3. 10.5 to 13.5. It's also a range of 3 if I subtract those. So my answer is going to be range and asymmetrical. Let's see how we did across the state of Texas. So this is right in the middle of the test, 17th most difficult. You see that we only get 42% of our students get full credit. But if you kind of take that together with how many students got partial credit, another 42%, now we're looking pretty good. 84% got 1 or more points here. So there's really only two choices that we need to make. Assuming that the students were familiar with symmetrical and asymmetrical, right? That is a vocabulary term we have to be familiar with, and we can visually just look to see whether they look the same or they don't. I think the issue might be with, calculating all three of those, the median, the mode, and the range, and just taking the time to do that, because a lot of times what we probably will do is we'll just kind of guesstimate it. And then if you really don't feel like looking at it too much, it probably makes sense for the median to be the same. And I would assume a lot of students probably just kind of looked to see that they looked like they were kind of evenish. And so they probably selected that one rather than actually doing the work of identifying the exact middle number and recognizing, right, that they were in two different locations. So we just need to provide students with an extra few opportunities to practice this, calculating the median, the mode, and the range. And rather than selecting those as one of the correct answers as the same, right, go ahead and just write out. So they have to calculate all three of those. And then taking a little bit of time to make sure we do really understand the difference between a symmetrical and an asymmetrical graph. Number 33, we are looking at the constant of proportionality. This is TEKS 7.4C in reporting category 2. It literally says we have a table here. We need to find the constant of proportionality that relates to y and x. Take a look at our reference materials. It's me that line 2, k equals y over x, and that k is the constant of proportionality. So let's do what the reference material says. Let's put y over x. Right, so what are we going to get here? Y over x is going to equal this 12 over 3. It's going to equal this 20 over 5. It's going to equal 28 over 7. All of those simplify to 4. That's it. That is our answer. B. Let's see how we did across the state of Texas. So this was the 11th easiest here, and we see that our students did fairly well. We got over 50% of the students getting this correct. So how do we get some of these incorrect? Well, the easiest thing to do is, instead of the y over x, what if you did x over y? You just inverted that. Now you're going to get 3/12ths. You're going to get 5/20ths and so forth, and you are going to get that 1/4. So if you just invert it incorrectly, you are going to do the work and still get the wrong answer. Now, these right here, right? If you do the 1/8 or the eighth, you see they're reciprocal. That's if we just, have no idea what to do. Maybe we subtract, right? 20 minus 12, or maybe we add, right? 3 plus 5. So we actually had a good quarter of the students that really had no idea how to attack this problem and just started taking numbers and just adding or subtracting them. For number 34, we are looking at volume, a readiness standard, TEKS 7.9a, in reporting category 3. So we have a box, and they already tell us the shape here. It is shaped in a rectangular prism here, and already give us the volume of 384 cubic inches. So we have the base, we need to find the height. Well, let's draw, right, our rectangular prism here. I'll just make it kind of tall and thin. And what do we have here? Well, we say the volume is 384, so that's typically what we're searching for. But they go ahead and give that to us, 384 cubic inches. And then the base, right? So what does that mean, the base? Well, let's go back to our reference materials. You are going to see that when we're looking at volume of a prism, very bottom line there, V equals BH. Volume equals base times height. And typically, they just give us the dimensions of the base. We have to find uh, that calculation on our own because that's the area of the base is what we're looking for. But they already give it to us, 64 square inches. So that's 64 square inches. And so we're just looking for the height. Well, if volume equals base times height, I'm going to substitute in my 384 for my volume. I'm going to substitute in my 64 for my base. Just looking for the height. I just need to isolate that variable. Let's just use the properties of operations here. Divide both sides by 684. That will give me that h by itself. So how many 684s can I put into 384? Well, if I'm thinking of the first digit here, 6 going into 38, let's try 6. And that's going to be 24. Yeah, 384, just nice and even. So my answer here is just 6. 6 inches is my height. And my answer is A. Let's see how we did across the state of Texas. So you can see this is the sixth easiest problem. Almost 3/5 of our students got it correct. So let's take a look at C. What's the confusion there? Well, remember we had our rectangular prism, and they went ahead and gave us all of the dimensions that we need. We didn't need to calculate the base. Well, if we are a little bit confused there, right, we still see our volume as 384, but if we're not used to getting the entire base, right, that's that 64 inches. And if we're not used to just seeing that on its own and we think, well, we have to calculate it somehow, right? What happens if we take that 64 and cut it in half and get that 32? Now, that's not obviously how we would find the base, right? We would need to find the square root of that rather than cutting in half. But if you take that 32 and then you divide that 32 into this 384, right? Because basically you're cutting your divisor in half, which means your dividend is going to, or your quotient is going to actually end up being doubled. That's that 12 right there. So students that made this mistake still had difficulty with this basic formula, V equals BH, and they just didn't quite believe that 64 was what we needed. They wanted to calculate it somehow, and so they cut it in half, maybe one for each side, and then they decided to divide that into 384. So this just means we have to provide students not only with opportunities to find the volume, if we give them, the side lengths and the height, but, solve for the height if they're given the volume and the base, or solve for the base if they're given the volume and the height. For number 35, we are looking at predictions from simple experiments. This is TEK 7.6a, a reporting category 1 readiness standard. So we've got some scores here for basketball games, and you notice these scores are kind of falling in these bands, these 10-point bands between 96 and 105, and so on and so forth. So we need to use the data in the table, and we need to make some predictions. We have some drag and drops, more likely, equally likely, less than likely. And so let's see, scoring 96 to 105, and the next game is, well, let's look at our 96 to 105, right? So we've got 19 games. So if we're using these predictions to predict the future, then we're not necessarily using any kind of theoretical probability, right? This is actually going to be based on what has happened in the story itself, or based on what has happened in the problem itself. And so this would be, a simple experiment. And what we need to do is we need to make a prediction. So I got my 96, 105. I've got 19 games that have scored in that range. Look at this 136 to 145. That's the very top band. So just looking at these data, right, you can say, well, 96 to 105, right, is greater than the 136 to 145 because that's your 19 to 3. So based on that data, it is definitely more likely, since this is much greater, over 6 times greater, more than likely that they're going to score that than they would the 136, 145. That's the smallest. Then let's just look at the second one. I've got my 116 to 125. So I've got my 17 right there. So 116 to 125, that's 17, is blank likely than 106 to 115. Okay, so that's 21. 106 to 115, that's 21. So just look at it like that. Okay, it's less likely, right? Less likely. Because honestly, this is that's the highest scoring band right there. There's 21 games in there. So that's going to be less likely. And that's it. That's all we need to do here. Let's just look at that data and make some predictions. So let's see how we did across the state of Texas. So this was tied for the ninth easiest. You see, we had over half our students get full credit, right? That's 2 points. But even if you add the partial credit then in there, right, you're just looking at about 72%. So that's still, I think, a little bit on the low side, getting at least 1 or 2 points. I think the issue here is whether they were looking at the scores, right, or whether they were looking at the number of games. There's two different pieces of data, right? If you're looking at the 96 to 105, that's definitely less than 136 to 145. But our answer is more likely than because we weren't looking at the score, right? We were looking at, well, how many games did they win? That 19 to 3. So that's what shifts that. And then the same thing here. We've got this 116 to 125. Those numbers, right, are greater than this 106 to 115. But if you look at the scores of the game itself, right, you've got your 17, and then you get your 21. That's what shifts it. So I think that's kind of the trick, if we need one for this problem, is some students might have been looking at the score bands rather than the number of games. That just means we need extra practice on how to read these problem situations and which column to look at when we're actually making our predictions. For number 36, we are calculating unit rates. This is TEKS 7.4b in reporting category 2. Very simple problem here. Shopper is going to pay $3.95 for 5 pounds. Right, so we've got, let's just draw a strip diagram here. So I've got $3.95, right, and then I've got 5 equal pounds. What is the price per pound? So I'm looking at a ratio. So look at that. They give you price per pound. I use LB for pound. So what are the prices? Well, I've got $3.95. And they've got 5 pounds, right? So look, that's all we're going to do. We're going to take our 395, we're going to cut it into 5 equal chunks. So 5 into 395, make sure we get our decimal up there. Right, that's going to be 7, almost 8, 35. And that's going to be 9. And that's it. Right, 79 cents per pound. If you multiply that by 5, you're going to get that 395. So that is our answer. It is B. We'll see how we did across the state of Texas. So we finally found it. This was the number one easiest problem in the entire test. Look, almost 4 out of 5 students get it right. There's nothing about any of these incorrect answers that really seems like they tripped students up. We're just setting up a basic ratio, 395 over 5, and as long as we can do our division correctly, we're going to get that right, and it looks like we've got this standard down. Good job, state of Texas. For number 37, we are looking at the circumference and area of circles, a readiness standard, TEKS 7.9b, and reporting category 3. So we have a circle here, and let's go ahead and just draw something so we can kind of visually represent it. So I've got a circle. What do we know about the circle? It's got a center point, radius of 4.5. So radius, remember, is from the center out to the side, straight line. I drew it to the right, but it could be honestly in any direction, right? We need to find the circumference. Okay, so the circumference is, I always think of like this word fence that's kind of sitting there almost in that word, that last part of circumference. A fence goes around a yard or a building, and the circumference goes around. Think of it like the perimeter. So let's look at reference materials. We see circumference right there. Circle is 2 pi r. So if we're not sure what that pi represents, we do have that down at the bottom. Remember, that ratio of circumference over diameter. It's about 3.14. So 2 pi r. That's all we need to know. Circumference equals 2 pi r. That's our formula. That pi represents 3.14. So let's say 2 times about 3.14, and then they give us our, our radius of 4.5. So I can multiply this in any order to find my circumference. To make it a little bit easier, watch, I want to multiply this 2 times 4.5. You can, commutative property of multiplication lets you reorder it. Watch what happens if I do that. 2 times 4.5, right? Then times the 3.14. That's just 9. I'd rather do 9 times 3.14 than, try to multiply that. Rather not do it. So let's do 3.14 times 9. Always make it a simpler problem if you can. So that's going to be 6, 36, that's 9, it's 12, 27, 28. 2 digits behind the decimal in the factors, 2 digits behind the decimal in the product. 28.26 or 28 and 26 hundredths centimeters is our answer, B. Let's see how we did across the state of Texas. So this was the 7th easiest problem here. 57% of our students got it right. You notice that some of us kind of got tripped up by that 14.13. About a quarter of us did that. Well, if we look at these, right, you see that that's double, right? The correct answer is double the A incorrect answer. Well, remember, we had 2 different formulas. We could have done C equals pi d or C equals 2 pi r, and that's because we know the diameter, right? We can substitute in the diameter by 2r. So the diameter equals 2r, double the radius, right? And so what happens? Well, if you don't double the radius and multiply that by, you're going to end up getting this C equals 3.14 times this 4.5. So some students probably just incorrectly used the wrong formula. They substituted in the 4.5 for the diameter, which it's not, and that's what gets you up here. And it's also a harder problem because that's a lot of decimals you have to worry about. So we just still need to work on helping students select the right formula and make sure that we're using, in this case, C equals 2 pi r rather than C equals pi diameter because they did not give us the diameter. And we are finally at the end of the test. Number 38, Equations and Inequalities. This is a reporting category 2 readiness standard, take 7.11a. So we have to model this equation here. We need to find what makes x true, but we've got this key that we could use, right? So let's just substitute in what they have here. So my x's are these long rectangles, right? So I've got x, 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 and then there's no x's on the right, and then the squares are just 1. All right, so let's see, how many x's do I have? I've got 3 x's, and then I've just got 1 afterwards. And there's nothing that they showed us to show that there's a negative. Sometimes they'll be shaded, so until they tell us differently, everything's positive. Then I've got 7. So that's all we're doing there. 3x plus 1 equals 7. Well, how do we isolate that variable? Well, we can actually do it now visually, since they gave us all this, right? So let's see, we could, subtract 1 from each side, right, to keep the equation balanced. And that's going to get 3x equals 6, but we can visually represent that, right? I'm just going to drop off 1 from each side, so it's still a balanced equation. Now, right, if we're just looking at the equation itself, we'd want to divide by 3, since that's the the inverse operation of multiplying by 3, which is what's happening to that x right now, right? So let's divide each of these into 3 sections. So that's going to be 1, 2, 3. You see how I have an x isolated now? Do the same thing here. 1, 2, 3 equal sections. So x equals 2, right? Because I've got a section, an x, and then I've got a 2. So looks like my answer is 2. Let's just double check to make sure that's going to work. Right, I'm just going to put 2, 2, 2, and 1. So remember, we're adding here. 2, 2, 2 is 6, and 1 is 7, right? And remember, all of these together made a 7. So 7 equals 7. That means we did check. Our answer here is C. And let's see how we did across the state of Texas. So this was the 22nd most difficult, actually on a 38 question test. That's a little bit more on the easy side, but still less than 50%, right? 47%. So how did we get, we didn't really, it looks like we chose D very much, but how did we get A or B? Well, if we set this up correctly here, right? 3x plus 1 equals 7. And then rather than subtracting 1, we actually added 1 for whatever reason, right? To think that's going to, that's going to simplify the equation. We would end up with 3x equals 8, right? And then you just divide by 3 and you get this 8/3. So this student at least tried to set it up correctly. Any students that got this would need extra help with how do you solve for x, right? Using the properties of equations and adding 1 to both sides. See this, here's the problem. That's not going to work right there. Adding 1 to 1 is going to get you a 2. It's not going to eliminate that 1. And then B, well, if you take a look at B, what that student most likely did, right, is just wasn't really sure as to how this worked. So they just counted the number of rectangles, right? So there's 3 rectangles in a square, so there's like 4 quadrilaterals over there. There's 7 over here, and they just wanted to put the x somewhere, so they put the x on the left, and you end up getting this 4x, right, equals 7. Then you divide both sides by 4, right, and you get the 7/4. So this student probably, if they got this answer B, they probably need some extra work on how to properly read this using a key and set up an equation to isolate for the variable.